In today's video, we're gonna learn about how not to get kicked out of your house. Let's go! Hello everybody, WeiEn Physics here, and this is another episode of 5 Minutes Physics where you learn physics in less than 5 minutes. Today's video is all about resolution of forces. What is a resolution of forces, or what does it mean to resolve a force? Well, we know that two forces can combine to become one resultant force. So that means one force can also be split into two components. This reverse process is what we mean by the resolution of forces. Now, resolution of forces can be either done graphically, that means by drawing, or using trigonometry, that means by calculation. I'm not a good artist, so we're gonna stick to trigonometry today. So imagine we have a force F, which is the green arrow, that is 30 degrees above the ground. This force F can actually be broken down into its horizontal component and vertical component, namely Fx and Fy respectively. Now, if I were to move Fy to the right side of the diagram, that will result in a right angled triangle, with the green line, the original F, as the hypotenuse, the red line, Fx, as the adjacent line, and the blue line as the opposite line. With that said, we can now bring in our trigonometry equations for right angled triangles. Sine of the degree is equals to the opposite divided by the hypotenuse. Cos of the angle is equals to the adjacent divided by the hypotenuse. And the tangent is equals to the opposite divided by the adjacent line. So now, if I take my first equation, which is the sine theta, that is equals to the opposite divided by the hypotenuse, I can substitute the values whereby theta is an angle that is 30 degrees, the opposite would be Fy, and the hypotenuse would be F. So from here, I can get Fy is equals to F sine theta just by moving the equations around. As for the second equation, cos theta is equals to adjacent divided by the hypotenuse. Again, theta here would be the same 30 degrees. The adjacent line would now be Fx, and the hypotenuse will still remain as F. So in this case, when I move the components around, I get Fx is equals to F cos 30. So by using these two equations, I am able to find what are the horizontal components and what are the vertical components for a single force. How do we actually use them? Let's have a look at the example. Bob just got kicked out of his house by his parents because he didn't know how to calculate resultant force and resolve forces. He pulls his toys with a force of 17 newtons at an angle of 40 degrees to the horizontal. What are the horizontal and vertical components acting on the box? So we can see the diagram here has been drawn for you, whereby he's pulling with a force of 17 newtons and the rope is 40 degrees to the horizontal. So I'm going to replace all the forces with the force diagram like so. So the horizontal component for the 17 newtons force, which is Fx, is equals to F cos 40, which we get by replacing the equations we had just now. So that is equals to 70 cos 40, which will get me 43.62 newtons. As for the vertical component, Fy, that is equals to F sine 40. Again, substitute the F by the original force, 70. So 70 sine 40 is equals to 45 newtons. So there you have it. That's how you break down any force into their horizontal and their vertical components. That is the resolution of forces. I am WeiEn Physics, and I'll see you in the next video. Remember, never stop learning.